So it does say that we need to verify that the segment lengths form a triangle before we actually solve it, okay? Do you guys remember what the test is to verify that 3 lengths form a triangle? Christina? Very good. So when you're doing this c squared compared to a squared plus b squared, that's to see if it's right, obtuse, or acute, right? Do you guys agree? Yeah. But in order to see if it's a triangle, you have to do what Christina said, which was add the 2 smallest and make sure those 2 are bigger than your biggest side. Does that make sense? Do you guys remember that? So what are the 2 smallest sides for the first one?
5 and 12.
5 and 12. So when we add 5 and 12, we get 17, right? Yeah. Is that bigger than 13?
Yeah.
So we've got a triangle. We're good there, okay? Second thing that we have to do is use a squared plus b squared and compare it to c squared. What's my c going to be here? 13 is going to be my c. I'll make 5 my a and 12 my b, okay? So we're going to do 5 squared plus 12 squared. Don't say equals. Just compare it to 13 squared. And you should have gotten 169 compared to 169. And they're equivalent, correct?
Yeah.
When they're equal, what kind of triangle do we have? A right triangle, okay? How many people got that one right? Let's go. Okay, number 10. Again, you can't just start by doing it. What do we need to do first? Good. So we should have added 5 and 7, right? You would have gotten, I think that's 12. And that is definitely bigger than 8, right? So we're good. We've got a triangle. Second thing that we need to do is do 25 plus, because this is going to be A, this is going to be B, this is going to be C. So 25 plus 49 compared to 64, correct? This should give me 74 compared to 64. Is that right?
Yeah.
And this one's bigger?
Yeah.
So what do we have? It's not obtuse. Acute, okay? This is an acute triangle, okay? One way I want you to think about it, right? If one side's really, really large, right? Almost like visualize it. If one side, that c squared, is really, really big and the other 2 are small, what kind of triangle is that going to make? This is going to be obtuse, right? No? All right, let's jump into it. So, in 9.2, we talk about 2 distinct special right triangle sets, okay? And I want you to write these down. The first one is a 45, 45, 90. Who's already complaining? That's so sad. And then a 30, 60, 90, okay? Now, just by those names, what do you think the 45, 45, 90 and the 30, 60, 90 is referring to? Giselle? The angles, okay? The angles. Okay? Because obviously if it's a right triangle, what does one of the angles need to be? 90. And if one of them is 45, the other one has to be 45, right? And if one of them was 30, the other one would have to be 60 and vice versa, okay? So when they're talking about these 2 special scenarios, it's based on the angles that were given. Giselle, what's up?
What makes it angles? Because you can look at it from sides too and it would still equal.
We're going to see that. We're going to see that. You're absolutely right. So we'll see some scenarios. Okay, so the first one that we're going to learn about is called that 45, 45, 90 triangle theorem. It says in a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg, okay? So, in other words, we've got 2 angles that are 45 degrees, right? And then we've got 2 sides that are both length A. Can anyone tell me why do these legs have to be the same length in a 45, 45, 90? Why do the 2 legs have to be the length of A, and they have to be the same? Dylan, what do you think?
They make a 90-degree angle. So.
They do, but that's not why they have to be the same. Savannah, what do you think?
Because they're isosceles.
Why is this an isosceles triangle?
It's 45 to 90, and then it's also 45 to 90. And so they're going to be the same.
Excellent. So highlight those two 45-degree angles, okay? Whenever you have two angles that are the same inside of a triangle, right? A light bulb should go off in your head. We're dealing with an isosceles triangle, right? So from here, the two angles across from those, the two sides across from those angles need to be the same length. So we know these two are A, and then we get A times the square root of 2. Now, this is going to be a fun little exercise, okay? We're going to prove why this happens. Why is the hypotenuse every single time going to be A times the square root of 2, okay? And we'll do it together. So, do you agree that we can apply the Pythagorean Theorem here?
Yeah.
Why? It's a right triangle, okay? So we're going to write A squared plus B squared equals C squared. Now let's figure out what our A would be, what our B would be, and what our C would be. What would our A be?
One of the sides.
One of the sides, one of the legs, right? What's the measure of one of the legs? A. So let's make this one A. So A is going to be A. What would B be? A as well. The other one though, right?
Yeah.
And what would C be?
A square root of 2.
Good. Now, the fact we're proving this part, okay? So we're going to leave C as C. We're not going to replace it with the square root of 2 times A, okay? You guys following? All right. So let's replace A and B with A's. So we've got A squared plus A squared equals C squared, okay? All I'm doing here is, since we said B was going to be A, right? We're just substituting that in for B. You guys with me, or did I lose you? We're good? Okay. What is A squared plus A squared, Xavier? It's 2A squared. Do you guys agree with that?
Yeah.
So we've got 2A squared equals C squared, correct? Now, remember, we're trying to figure out what would the length of our hypotenuse be. So let's try to solve for C. What would you guys do to solve for C here? Mariana? Take the square root of both sides. So take the square root of both sides.
I have a question.
Hold on. Hold the question till the end because we're almost at the beauty part, okay? So what's going to happen on the right side? Giselle?
The square and the square root is going to cancel out because
Excellent.
they negate each other.
Very good.
And what's on the left side?
So we've got C equals. Now, remember, there is a property of exponents, okay? We can apply this square root to each of the terms inside separately, as long as they're being multiplied. Okay? So I'm going to rewrite it as the square root of 2 times the square root of A squared. Are there questions on what I just did there? Yeah, Savannah?
Why are we not using it as a2 plus b2 equals a to the r square root 2? Instead, we never substituted this.
Yeah, so we're proving this part right here. So we're going to leave it as C. That's a really good question. Okay, does it make sense now why we're leaving it as C? Okay.
Oh, so we're trying to get A2.
Correct. We're trying to get the square root of,
That's why-
or A times the square root of 2, okay? All right, so are we cool with breaking this up as the square root of 2 times the square root of A squared? Does that make sense or no?
You're just distributing.
So do you guys remember when we had I don't know, let's say we have the square root of 8, right? Do you guys remember when we broke this down into the square root of 4, bless you, times the square root of 2?
Yeah.
We can do that with variables as well. So we had the square root of 2A squared, right? We can rewrite it as the square root of 2 times the square root of A squared. Okay, that's a property of the radical, okay? So, and then do you guys agree that we would just write this as 2 times the square root of 2? Okay, this is just a little tangent, so put a star next to it. It has nothing to do with this problem. Christina? So we'll talk about that in a second. It is going to go away. You're absolutely right, okay? So now the last step is these are going to cancel out. Do you see that? The square root and the squared. So we just get the square root of 2 times A equals C. So our last side, did we just prove that same thing? Okay, so this is why no matter what, whatever your leg is, your hypotenuse is going to be the square root of 2 times that leg length. In what kind of triangle? What special case are we dealing with? Isosceles, and otherwise known as? Giselle? A right triangle, but what are so special about the angles? 45, 45, 90. Okay? So this is the 45, 45, 90 scenario.
That's the same thing. 2A, square root of 2A is the same thing.
Yep. Okay? Now, Go ahead. Do you see all this writing on the right? Copy it over to the next slide because the next slide is saying to prove it, but I wanted to prove it on this slide. Okay, so copy this over. And so this writing on the right, all this stuff, copy it over to the next slide. Okay?
Oh, this is so much algebra.
It is a lot of algebra.
Not liking it.
Aren't you happy?
No.
Match it to this slide. Okay? Guys, are we given any information about the angles from the diagram?
Yes.
Right off the bat?
Yes.
Kind of. But, like, does it tell you what this angle is?
No.
Does it tell you what this angle is? Can we figure it out?
Yes.
Why?
Because you have an
Because we have a 90-degree angle.
We have 190. That helps us. Xavier? The legs are the same length. Do you guys see that? So what kind of triangle is this? Isosceles. So it has to be a 45, 45, 90. Do you guys agree with that? Okay. So anytime you're dealing with an isosceles right triangle, 100% of the time it's going to be the 45, 45, 90 scenario. Okay. So we say that this is going to be 45 degrees. This is going to be 45 degrees. Okay. And now we're going to apply our knowledge. Okay. So X is going to represent that A length. The other X is going to represent that A length. And the 6 is going to represent what?
C.
C. In other words, we said C in a 45, 45, 90 was equal to what? The square root of 2 times A, right? So now watch.
All of them,
What?
they're all gonna be square root.
Only the hypotenuse.
Well, like
So-
for all the 45, 45, 90, the hypotenuse is gonna be square root 2a, I think.
Yes, for 45, 45, 90 is the square root of 2 times A. Zoe, what's up? Say that one more time. No. Okay, so let's check it out. So I want you guys to take, this was the side that we're given, right? The 6. We're going to use this to solve for A, and that'll help us figure out what X is, okay? So we're going to say 6 is equal to the square root of 2 times A. What would we do to solve for A, guys?
Would you square root 6 too? Or
No. That's when A is squared. What would we do here? Does anyone know? Giselle?
Should be the square root.
Nope.
Subtract a.
So what's going on between the square root and A? What operation is going on here?
Also you would
Multiplication. How do you undo multiplication? You just divide. By what though?
By a.
No.
divide by 2a.
No. The square root of 2. We want to leave A on that side, right? Because we want to get everything else away. So divide by the square root of 2. And we've got 6 over the square root of 2. These are going to cancel. Equals A. Now, plug that into your calculator. All right, so we got A equals 4.24264 ... Now, remember, what are we rounding to in this class? The tens place. So we're looking at the 2. The 4 is going to round it down. So we're just going to write it as A equals 4.2. You guys cool with that?
Yeah.
Okay. Now that we found A, it's not asking us for A, it's asking us for the value of X. But what is X going to be equal to?
X 44.2.
It's going to be the same thing as A. Because do you guys agree that in the beginning, we said that A is going to be the same length as one of our legs?
Yeah.
So X and A are the same thing. So X is equal to A. So X is equal to 4.2. Christina? Triangle scenario is called the 30, 60, 90 triangle. Okay? So in a 30, 60, 90 triangle, the hypotenuse is going to be twice as long as the shorter leg. And the longer leg is going to be the square root of 3 times as long as the shorter leg. I'll let you guys copy this down, and then I want you to pay very close attention, okay? Okay, take a look. So whatever your angle 30 is, that's going to set up your problem. I want you to highlight the 30, okay? The side across from that 30, you're going to make A. Then the other leg right? Not the hypotenuse. The other leg is going to be a times the square root of 3. In other words, opposite the 60. And your hypotenuse is going to be equal to 2a. But you have to start with the side opposite the 30 degrees. Okay?
Wait, so they're all A?
They're all in terms of a, but they're all different values. So the side opposite your 30 is going to be a. The other leg will be a times the square root of 3. And your hypotenuse will be 2 times a.
Is 2 times A, that's the C,
Correct.
and that's the B.
Yep. Yeah.
Wait, so the Pythagorean theorem is applied because you substitute a for b on a square root of 3? Like, I don't get how that turns into b and the other one turns into c.
Got that from the special triangles scenario. Okay. Remember, the other leg, the longer leg, is going to be a times the square root of 3 or the square root of 3 times a. Okay. Next slide. How do we know that this is a 30, 60, 90 scenario? Christina? Good. So there's 60 degrees down here, but how do we know that this last one is 30 then?
Because the triangle has 180 degrees.
Good. A triangle has 180. Minus 90 minus 60 makes this what, Carlos? 30. Okay. So we know we're dealing with the 30, 60, 90, right? Start with the side across from your 30. And we make this 5 equal to what? A. Okay. Now, your other side, that's a leg, which is this x. Do you guys agree? Because it's opposite the 60 is going to be equal to what? The square root of 3 times a. Okay? So this side opposite the 60, in other words, our other leg, our longer leg, is going to be the square root of 3 times a. And then y is going to be what?
2A.
2 times a. Okay, I'll walk through it one more time. So, do you guys agree we have to start with a 30, right? The side opposite 30 is 5, right? So we say a equals 5, because that's the smallest one, right? Then you go to the opposite, or the other leg. Agreed? So the side opposite the 60, not your hypotenuse. That side is going to be equal to the square root of 3 times a. And then the hypotenuse is going to be 2 times a. Again, guys, this is a special triangle scenario, okay? The more we do this, the more you're going to get into custom. Please write, I forgot to write this at the top. This is a 30, 60, 90 example based on what we figured out together, because it was one of the angles was 60, one of the angles was 90. Okay. Yep, go ahead.
We get the square root of 3a again.
Square root of 3 times a. So, all right. So, from here, okay, we know that a equals 5, right? That was from our first one. We know that x is going to be equal to the square root of 3 times a. And we know that y is going to be equal to 2 times a. Let's solve for x first, right? Do you agree that since we know a needs to be 5, we can just substitute 5 for a? And write x equals the square root of 3 times 5? Do you agree? Because a needs to be equal to 5, right? So plug that into your calculator. Do the square root of 3 times 5. Times 5. Did you get 8.66?
No.
Did anyone get 8.66025?
No.
8.66025 ... and then it's x equals 8.7 because we're rounding to the tens place. Okay, did you close your parentheses? Okay, you can't multiply 3 and 5 underneath the radical because that'll be the square root of 15. Okay? You have to treat them as separate because that 5 is not underneath the radical. Okay, then the next one, we just do y is equal to 2a. What was a? It was 5, right? So it's 2 times 5, which is 10. So x is going to be 8.7 and y is going to be 10. And then please, 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 guys, cross out this bottom portion. That's if we were doing this lesson without a calculator, but we're not. Okay, we are using a calculator. All right, guys, now I know you guys probably have a lot of questions, okay? But I want us to see at least 1 to maybe 2 more examples before you guys ask those questions, because I think some light bulbs are going to go off.
Question about this, though? Like about the answer.
Okay, go ahead. Mm-hmm. So I just substituted 5 for a. And 2 times 5 gives me 10.
Oh, that's because 5 is A.
Correct. Okay? All right, let's try one more. All right, so remember, when these problems don't give us a diagram, what should we always do?
Draw.
Step number 1, draw. Okay? Draw a triangle. No, excuse me. Draw the figure. So we're dealing with what kind of figure here?
A square.
Square, right? So draw a square as best you can. You guys probably draw better than me.
You can hold it on notability.
I know, but I'm not in notability. Okay? Now, it does tell us, second thing we do is we have to add the piece of information that's given in the problem. So we need to add info, right? What information is given in the problem?
Length of 6.
6 for what? What's the 6? The diagonal. So draw a diagonal and label it 6 units long. All right? Now, it also says it's asking us for the perimeter of the square. Step number 3 for these types of problems is add properties, right? So what do we know about the properties of a square? Zoe? All the angles are 90. Perfect. So let's put a 90 here, a 90 here, and we know that these two are 90, right? What else do we know about a square? All sides are the same, so put congruence marks here. All right. Now, I personally see enough information to apply a special triangle theorem here. Do you guys see it as well? Savannah? It is, but remember, let's try to use a special triangle theorem. Emma?
45, 45, 90.
Why is it 45, 45, 90?
Because it's a right triangle and it's isosceles.
Okay, so step number 4, right? Do you agree that, let's just look at this bottom triangle right here, okay? Draw it out again, right? We've got 2 sides that are the same length. It's 90 degrees, and we know the hypotenuse is 6. Do you guys agree? So, this is a 45, 45, 90 triangle. So now, what do we know about 45, 45, 90 triangles? Christina? Yep, these 2 sides are going to be the same, so these are both going to be A, and then our hypotenuse is going to be equal to what? That 6 is going to be equal to what? A times the square root of 2. You guys with me or not? Kind of.
This drawing is like distracting me. Like, see?
Okay, so do you guys agree we don't really know what A is from either of these, right? But can we use this to solve for A?
Yeah.
So we're going to rewrite 6 equals A times the square root of 2. How would we solve this for A, guys? Divide by the square root of 2. So these square roots of 2 are going to cancel. Is this okay? Can you guys see this color? Not really? Okay, let me change. So 6 equals A. Is that better?
Yeah.
Okay, so now we've got 6 over the square root of 2 equals A. And then plug it into your calculator, okay? What is 6 divided by the square root of 2? I got 4.24264 ... And this rounds to A equals 4.2, right?
Yeah.
But that's not what it was asking us for, right? We just found that this little side is 4.2. How do we find the perimeter of it?
You multiply by 4.
Yeah, you can add up all the sides because they're all the same length, right?
Yeah.
Or just multiply it by 4. So we would do 4.2 times 4 in our calculators. And I think we get 16.8, right?
Yeah.
So that's our perimeter.
Okay. Make it more sense.
An equilateral triangle has an altitude length of 5. Find the perimeter of the triangle. So let's set it up. Let's draw it out. So it's equilateral. What does that mean?
All sides are equal.
All sides are the same. We also know equilateral triangles also have what? All the same angles, okay? So it's equilateral. So step number 1 is draw it. Step number 2, add info. What is the info?
All sides are congruent and all angles are congruent.
Those are the properties of equilateral. What info in the problem did it give us?
The
Mariana?
altitude is
The altitude. So drop a perp down from the top vertex down to the base. Make sure that it makes a 90-degree angle. That's our altitude. How long is it?
5.
5 units. So put a 5 in there. Third step. Properties. Now, Emma, what do we know about this triangle?
All the sides are congruent and all the angles are congruent.
Excellent. All the sides are going to be the same. And all the angles are going to be the same. More specifically, what is the exact measure of each of the angles? Zoe? 60. So 60 degrees, 60 degrees, and this whole thing is 60 degrees, okay? Now, it's kind of hard to see it like this, so let's draw it again over here on the right. Just draw one of the right triangles. I'm going to draw the one on the right. And we know that this angle is 60, this angle is 90, and this is 5. What scenario are we dealing with? 30, 60, 90, baby, okay? 30, 60, 90. Fill in that last side as 30 degrees. And we're always going to start with the side opposite the 30, right? That side opposite the 30 is, what should we label it? A. The side opposite the 60 is going to be equal to what? Zoe? Square root of 3 times A. And the hypotenuse is going to be what? 2A. One of these will create an equation we can solve. What can we solve here?
The square root of 3 times a equals 5.
Good. The square root of 3 times A equals 5. So let's write that down over here. Square root of 3 times A equals 5. How would we solve for A, guys? Zoe? Divide by the square root of 3. Divide by the square root of 3. These are going to cancel. We're going to get A equals 5 over the square root of 3. And in your calculator, plug it in. 5 divided by the square root of 3. 2.88675. 2.88675 ... which rounds to 2.9. Okay? So we know A is going to be 2.9. And we're trying to find the perimeter. Well, if A is 2.9, how do we find the perimeter of this triangle?
You plug in a to 2a and a.
Ah, okay, we can plug it into 2A. Remember, guys, always compare it. Do you see where we got this triangle from our diagram? Do you guys see that? How that triangle that we just solved for is in our diagram?
Yeah.
Only half the side is 2.9. Stephanie? Sophia?
So you multiply by 2 and then multiply that by 3.
Excellent. Okay, so we have to multiply this by 2 because there's going to be 2 of them to make up a side. Do you guys agree?
Yeah.
And then multiply it by 3 to give us the perimeter. So 2.9 times 2, so this whole length of a side is what? 5.8. And then multiply that by 3, so your perimeter
Why do we multiply it by 3?
equals 5.8 times 3. So it's going to be 17.4.
Oh, wait, never mind.
You got it, Savannah?
Yeah.
The answers to the exit ticket are on the board. Go ahead and try to figure out how we got that. You can discuss with your neighbors. Go.